Hello everybody, welcome back. So in the last video we were talking about pressure, right? And this idea of pressure telling us about interaction. So obviously this is an important quantity to be able to measure. And in order to measure pressure, well, we have various types of gauges, types of devices that will do that for us, and we're going to look at a couple today. So the goals for this video are to be able to define the gauge pressure. And last time we were talking briefly about it. I'll describe more about what gauge pressure means and absolute pressure. But that's our first goal. What is gauge pressure? What is absolute pressure? And we're going to talk about various methods on how to measure pressure. And specifically how to understand how a barometer works. And we like to discuss a barometer because it's a nice discussion on pressure and how it's applicable. So first, let's start off with measuring pressure, right? There are a number of ways to do it. There are various gauges, and we've probably seen at least one of these types of gauges on the top three. We've seen gauges on a gas cylinder that tells us how much pressure is in our gas cylinder. We have those little tire pressure gauges to see what our tire pressure gauge is at. And of course, there's more scientific pressure measuring equipment, such as this one for measuring vacuum on high vacuum machines. So pressure gauges exist all around us, and it's, again, useful to know how do we measure pressure. And one of the most simple pressure measuring devices is a manometer. And essentially what it is it's a tube that is open on one side. This tube on the left is open to both. I'll explain why in a second. But it's a tube that is bent in a U shape and open on both sides. We put a ruler up to the side of it. And with this, we can measure what is the height of our fluid. Now, the height of our fluid is going to depend on the pressure being applied to either side of the liquid, right? Which is essentially saying how much force is being pushed down on either side of the liquid. When we look at these devices, though, most measuring devices are set to 0 when the measuring side is at atmospheric pressure. So when we look at this manometer, we would say that one side is a measuring side. That is the side that we will measure with. And then the other side is going to just be open to the atmosphere. And we set it to 0 when both sides are open to the atmosphere. And this is going to be the case for really any measuring device, even these car tire pressure gauges. When it's at 0, it's because the side that we put into the car is open to the atmosphere. So when we do this, we start to look at pressures as though they're what we call gauge pressures. And to understand that, we are essentially subtracting off our atmospheric pressure. I'll explain more in a second. So with our manometer, we can take the measuring side and we can connect it to something that maybe has a higher pressure, right? Like a balloon. So you connect a balloon to our manometer and it has some pressure P inside of it. And that pressure P is going to push down on the fluid on the right-hand side. And when it's pushing down on the right-hand side, that means the left-hand side is going to raise, but it's not going to raise forever. It's only going to raise until we get the net force at that level equaling 0, because that's when things come to a halt, right? Newton's second law. So we look at this height and we say when that height has the force on either side equal to 0, then we get no more movement. We get that the force on the left is equal to the force on the right. Well, force, we want to really look at pressure. And I was going to skip a step. Pressure times area is equal to the pressure on the right side, which we're just denoting as P, times the area. Area cancels out and you get the pressure on the left at this height is equal to the pressure on the right. And from here we look, okay, well, what's the pressure on the left? Again, we've set it to 0 at atmospheric pressure, so we're not considering the atmosphere. We're only considering the fluid above that location, like we did at the end of the last video. And what is that pressure? Well, that's the density of the fluid times G times the height of that fluid line, height H in this case. So we get the pressure on our barometer, our manometer, being rho G times the height of our fluid. This is one way to measure the pressure acting on an object. Now, what's interesting is if we were to take this and instead of putting a balloon on the right-hand side, let's say we make a manometer. So just draw one out real quick. Where instead of putting a balloon on this side, we put a vacuum. So let's imagine we hook it up to a container that has been vacuum sealed. If it's vacuum sealed, we hook it up to the manometer, and what's going to happen is we're going to get a rise on the right-hand side. So we look at our ruler, and our ruler would see a change in height that is negative, meaning that the pressure that we are reading here from our gauge, I'll use a G here for gauge, is equal to negative rho GH. The negative because the height on the left-hand side has fallen. We get a negative pressure. But negative pressure doesn't actually mean anything. Pressure is related to the molecules that are moving around and the kinetic energy of those molecules. That cannot be negative. So what is the negative here? Well, the negative here is because we set our pressure equal to 0 when we were open to the atmosphere. So what we really want to look at is not the gauge pressure, but instead the absolute pressure. That's the pressure that matters here. And how do we find it? Well, we take atmospheric pressure and we add to it the gauge pressure. So in this case, it would be the absolute pressure is equal to pressure of the atmosphere minus rho GH. And what's important is that this can never be less than 0. This is always going to be a number greater than 0. You cannot have negative pressures. You can only have positive pressure, hence the term absolute. So this is our absolute pressure. This is how it relates to the gauge pressure. The gauge pressure, which is defined to be the pressure measured by a gauge, essentially. Whenever you look at a gauge, such as the tire pressure or the gauge on gas cylinders, it's always giving you a gauge pressure, not an absolute pressure. And this brings us to the manometer. Now, a manometer is made, or sorry, this is not a manometer, a barometer. Now, a barometer is useful because it tells us about the pressure in the atmosphere. How it's made is we take this tube and we fill it up with some fluid. And after we fill it up with some fluid, we put a lid on it and we flip it over. And when we flip it over, what's important is that the area up here becomes a vacuum. It becomes a vacuum. What does that mean? That means that the atmospheric pressure up there is 0. Again, I said that pressure depends on the molecules that are present. Because we filled our tube all the way up initially before flipping it over, once we flip it over, there are no atoms to be up there. So we have a roughly 0 atmospheric pressure on the inside the tube. And then, of course, on the outside of the tube, we have regular atmosphere, right? We have our atmospheric pressure. So we take a look at this and we say, well, examining this point, that location at the bottom of the tube, where the bottom of the tube is equal to the fluid level at the outside. When we look at this point, we know that the pressure inside the tube must equal the pressure on the outside of the tube. The pressure inside is only going to be due to the fluid above it, right? Because again, there is no atmosphere above the fluid. So the pressure inside is going to be rho GH, and historically we've used mercury, and that's going to be useful in a second. The pressure on the outside is going to be the pressure due to atmosphere, and that's it. And since those two pressures must be equal to, our barometer will give us the atmospheric pressure equal to rho G times H, the height that this tube is filled up to in the atmosphere. And if we choose mercury, rho is going to be a constant. We can look it up. G is 9.8. That means that the height level of our mercury will tell us the pressure. And units of pressure, units of pressure is newtons per meter squared. But historically, there's another unit of pressure, mmHg. You've probably seen this at the doctor's office for a blood pressure check. And the reason why is because it's millimeters of mercury. If you know how high the mercury rises, you know what the pressure is in this other unit of millimeter per mercury. So that's where that unit of pressure comes from. It comes from this idea of pressure from a barometer, one of the first ways we've learned to measure atmospheric pressure. All right. So, again, goals of today. Gauge pressure and absolute pressure. Well, gauge pressure is the pressure that you will read off of any pressure measuring device. The absolute pressure takes that gauge pressure and adds to it the atmospheric pressure. So we have absolute pressure being atmospheric pressure plus gauge pressure. There are various ways to measure pressure, such as a manometer and a barometer. And we talked about how both of those devices work and how both of those measure pressure. And now that we have this understanding of pressure and that we have an understanding that it can be measured, we move on to what implications we can draw from pressure. And specifically, an interesting application that comes from this idea that pressure should be equal at equal heights. That'll lead us to some interesting conclusions. All right, I will see you in the next video. Have a wonderful day, and if you have any questions, please reach out and ask.